So I've just finished university, where I was studying physics and meteorology at the University of Edinburgh, and I'm now working as an education support officer at the Royal Meteorological Society. I'm just going to sort of go through why I chose the field, where it's taken me so far and where I want to go, and sort of just talk through my personal story, and hopefully you guys can get some useful information out of that. So this is my journey so far, kind of as a flowchart, and we can kind of go through that. And a lot of you are still at school now and deciding where you want to go. So that's where I'll start. As well as Kirsty, I'm from Scotland, so I didn't do A-levels, did Highers. And the ones with asterisks are what I did to advanced Highers. So again, quite science-based, but what I really loved at school was geography. I'm very passionate about the environment and the climate and ecology and conservation in general. And I really enjoyed that with geography, and that's what I wanted to get into. So I went to open days for environmental science and such like, and for me personally, they weren't quite technical enough for my liking. So I started looking at maybe physics or engineering, but that pulled me away from working with the environment. So I had these two subjects that I really enjoyed, and when I found physics and meteorology, it kind of married the two things that I really enjoyed together. So I could study the environment, but also in a technical nature, which was great. Along with this is, as everyone in our generation, climate change is such a huge thing for everyone. And in the news, a lot of jargon is thrown around. Experts are sort of explaining their research and throwing around these terms that I maybe understood, but I didn't quite know what they meant. And I wanted to know what was the science behind climate change in more detail. And physics and meteorology really helped me do that. Finally, I want to say is, as a kid, I was not obsessed by the weather. I think there's sometimes maybe a stereotype that to get into meteorology, you have to be really passionate about the weather. And a lot of people aren't. It's really great. That's brilliant. That wasn't me. And I still came into this field and I really, really enjoy it. So if that's you and you're maybe sort of a bit taken aback, that's completely fine. Like you can get into this field and it's really fantastic. So this led me on to the University of Edinburgh, where I studied physics and meteorology. And I'm just going to go through what that was like for me. First and foremost, it was a physics degree. So that meant a lot of maths, essentially. So you start off with classical mechanics, sort of looking about like Newtonian physics, maybe. And then it gets more advanced and you get to learn some really interesting stuff about quantum mechanics, relativity, looking at the universe. But with that, you also do some thermodynamics, which is really, really important for the meteorology that you're going to do. That, for me, started off with forecasting. So looking at the weather on a day-to-day basis and how that's changing. And once we got some more math skills, we started looking at atmospheric dynamics, looking at the mass behind the atmosphere and how that changes. And with that, you can start building climate models and looking how is that going to change in the future and using that to answer some really, really interesting questions. But the main thing is the skills that come from both of this, and they're very similar. As was said before, maths is quite important. You don't have to be a maths genius, but I think having a general interest in maths and getting a sort of a satisfaction from solving problems is quite important with meteorology. And another thing you learn with meteorology is coding. So this is something I'd never done at school, hadn't touched before university, couldn't tell you anything about it. But now I've done quite a lot of, and it's really useful. It's a fantastic tool that you can use in lots of things, and it's really good for employers as well. So when you start looking for jobs, if you can say you've done some coding and applied it to meteorology, that's really helpful. So within my degree, I did a couple of internships, and the first one I've called storm tracking, and that was at the University of Leeds at a PhD school called SENSE, and they are all about Earth observation. So what that is using satellite data to monitor anything about the Earth. So that could be ecosystems, it could be construction, but it could also be the weather, and that's what it was in my case. And what I was doing was trying to track and locate a storm that was responsible for heavy flooding in Jakarta. And once it was located and tracked, I could investigate that and look at the attributes of that storm and what caused the flooding. What was it about this storm that caused so much flooding? It was a really great experience for me because it was my first experience dealing with academics and working on research. And it's really great to see how PhD students and professors work together as a group to produce these papers and how they conduct the research themselves. And that was really cool. I also got to make some pretty cool charts and stuff like in the animation here. So this shows how clouds are developing with the grayscale, and the colors is the precipitation. And now you can see a box coming across, this yellow box. That's me trying to capture the storm that was responsible for the flooding. So yeah, it was a really cool internship, and I really loved the application of the knowledge that I had at uni. So that was at the end of my third year. I go back to uni for my fourth year, and at the end of my fourth year, I did a statistical internship. So this was at Lancaster University, and I was investigating something called change points. Now, a change point is essentially a point in a data set where it suddenly changes. So maybe there'll be a change in the mean or a change in the trend. And in particular, we were looking at circular change points. So if you wrap the data around itself, sort of as shown in those top two charts, it can become much more clear where the change point is. So in the first time series, it's quite unclear to see where the change is. However, when you wrap it around itself on 20 seconds, you can see clearly there's a big change every 10 seconds. I started applying this to some COVID case study data and found out some interesting results. But what I want to sort of say about this has nothing to do with meteorology. You know, it's completely different. It's not something I could have imagined myself doing. But the skills that I learned from meteorology allowed me to apply for this and allowed me to perform quite well at this. And it's such a dynamic subject that even if you start it and think, maybe this isn't for me, which is obviously completely fine, you've got such a wealth of skills from maths, problem solving, and coding that you can move into other industries. Maybe it would be statistics, maybe it'd be finance, maybe it'd be engineering or consulting. Hopefully you'd stay within meteorology, but if not, you can move into these other industries, which I think is really important. And finally, to do with the university, I just want to speak about my final year project, because this is something that I thought was really interesting. What I loved about this project was it coupled everything that I loved about my degree. I could finally use it for something to do with conservation and ecology. And what I was doing was investigating how the pitch of blue whales had changed and seeing if there was a link to climate change. The idea behind that is the Earth is warming up, and with that, the oceans are also warming up as well. And when water heats up, it means sound travels slightly differently through it. And what we were investigating is, would the sound of the whales change as it goes through the ocean because the oceans are warming up? And if so, are they changing their pitch as a result of that? And what was fantastic about this is I've got the conservation of whales, which provided my motivation. The meteorology is obviously heavily involved due to the climate change and working with climate models, which is really interesting. And then also physics, looking at the acoustical physics, how is sound going to develop throughout the ocean? So I just thought this was a really great project, and it's just an example of some stuff that you can do in terms of research if you're wanting to do a PhD or something, but even just while you're at university. So this leads to what I'm doing now. As I said, I'm working as the educational support officer to Sylvia. So sort of just helping her with the work that she does, providing some educational materials and helping students who are interested in meteorology. But I'm only here for the summer, and I'm at a stage where I'm thinking, what do I want to do next? Well, I think what I'm really passionate about is Earth observation, and that internship led with Leeds looking at storms really led me into that. And there's a lot of different applications that you can use in construction, but also ecology, which is really interesting to me. And what I love about it is it uses my meteorological skills, because to observe anything from space with satellites, you have to look through the atmosphere, and that means you've got to understand the atmosphere, and you've got to look through the weather, and then you can use that to see what is below, which I think is really interesting.